All right, going over the practice test homework from session 7. So number 1, an object accelerates at a constant rate of 5 meters per second squared. This means that the object, so remember for this, acceleration is the rate at which its velocity changes every second. So if it accelerates at a constant rate of 5 meters per second squared, that means the object increases its speed by 5 meters per second every second, decreases its speed in the 5 meters every second, doesn't move, has a positive velocity, moves 5 meters every second. So for this one, man, I don't like this question. So what they're looking for here is A. And the reason they're looking for A is because they're saying it's accelerating at a constant rate of 5 meters per second squared. The reason I don't like it is if you accelerate at a constant rate of 5 meters per second, it doesn't indicate direction. So accelerate and decelerate are not the same thing. So I would actually say this is not a great question in retrospect that I just missed. Because yeah, we don't know if it's increasing or decreasing. An acceleration of 5 could be doing either. So the thing to remember here is if your velocity is to the left and your acceleration is to the right, then you're slowing down. And if your velocity is to the right and your acceleration is to the right, you're speeding up. But if you're going to the right and moving left, you're slowing down. And if you're going to the left and accelerating left, you're speeding up. So I get what they're going for here. Not the greatest question. Sorry about that. I really need to make these videos before I assign stuff so I catch this stuff. Busy time. All right, number 2, starting from the origin, a person walks 8 kilometers east, 5 kilometers west the next day. What's the total distance traveled? The total distance traveled would be 13 kilometers E. So distance is a scalar. It doesn't care about direction. In this case, it's just 8 plus 5. If they asked for displacement, which is the vector, that would be 3 kilometers because it's the distance from where you started to where you ended, and you ended up 3 kilometers where you started. But they asked for distance, so it would be 13 kilometers. Truck travels east with an increasing velocity. Which of the following is the correct direction of the car's acceleration? So it's moving right and speeding up. That means your acceleration must be in the same direction as the car. If you skip to this question and need more explanation for that, please see problem 1. All right, so we got number 4. A modern car can develop an acceleration 4 times greater than an antique car. If they accelerate over the same distance, what would the velocity of the modern car compared to the antique car? So we're looking at a set distance with the same initial velocity, the same acceleration. So in this case, we know V naught, we know A, we know delta X. And we want to know how the final velocity compares. So the variable not listed here is time. That's the one we don't care about. So if we look at v squared equals v naught squared plus 2a delta x, v naught squared is going to go away because it says v naught is 0. 0 plus anything is anything. The 0 doesn't matter. So what we're looking at here is 2a delta x. So if I just plug in any number whatsoever, as long as it's the same, because we know it's over the same distance, and we know for the antique car, it's 1/4 the acceleration. So if I say the distance I care about here is just 1, and I'll say this has an acceleration of 1, which means this has an acceleration of 4 times as much, right? By the way, you don't need to plug in the numbers. You could just do this algebraically of, well, hey, look, if a number is 4 times as big in the acceleration, because I need to take the square root of 2, or I need to take the square root of that number, I'm going to get an answer that is twice as much, not 4 times as much. And the answer should be C. But if you can't see that mathematically, and all of you might not be at that point, with your comfort level with the math, make up some numbers and plug things in. So for the antique car, it would be v squared equals 2 times 1 times 1, which is the square root of 2. And then for the modern car, it would be v squared equals 2 times 4 times 1, which would be the square root of 8. So I'm taking the square root of a number that is 4 times bigger, and you could actually plug it into your calculator, take the square root of 8, square root of 8 divided by square root of 2, and what you should get is 2. So twice as much. All right, problem 6. 6, 7, 8, we're all using this graph, so I'm going to group 6, 7, 8 together on this particular worksheet. All right, so we got a velocity versus time graph. If you get a graph, it's very important that you take a look at what it is a graph of. What is the distance that the object travels in the first 4 seconds? Well, in the first 4 seconds, so there's a couple ways you can do this. If you did the summer work, you would have learned about area under the curve and slope. And we talked about this when we derived the equations, which is the area under the curve of a velocity versus time graph tells you the displacement of the object. So you could do the first 4 seconds. This is a triangle with a height of 8 and a base of 4, and area is 1/2 base times height. So 4 times 8 times half is going to give you 16. So it's going to be 16 meters. That option exists for you. However, if you're sitting here confused going, what the hell does area under the curve mean? That's okay. We didn't actually talk about this in class. This is a concept we're going to come back to. So if you don't know what any of that is, you can get away with this fine by using your kinematic equations, because we know that my initial velocity is v naught because you start at a velocity of 0 at a time of 0. I know my final velocity is 8 meters per second because I can find it up here on the line. I know my time is 4 seconds, and I know that I am looking for displacement. So the variable that I do not have here or do not care about is acceleration. Of course, I've got to find that first. So this is going to be a decent 2-step problem. And that's going to be, I'm going to use V equals A times T plus V naught. So divide both sides by 4. And you get an acceleration of 2. By the way, you've actually solved problem 7 as well. Now with that acceleration of 2, let me change to white so you can see over here. Now we can go ahead and say, well, delta x equals v naught t. So v naught t plus 1/2 a t squared. And so I get delta x equals 0 plus, let's see here, 4 squared is 16, and then half times 2 just cancels out, so it's plus 16, and this equals 16 meters, which is what I said it should be. For number 7, if you didn't want to do the kinematics, if you did do the summer work and you're aware of the graphs, the velocity versus time graph, the slope tells you acceleration. We talked about that when we derived the equations as well. So you could just go, well, I went up 8 over 4. 8 divided by 4 is 2. My slope is 2, so my acceleration is 2. What is the acceleration during the last 4 seconds? Well, if we're at a constant velocity of 8 meters per second here, then that means your velocity is 0, or your acceleration is 0, because you are, I switched it to white, because you are no longer changing velocity, and acceleration is a change in velocity. Number 9. As shown to the right, a ball is thrown straight up for point A when it reaches a maximum height at point B and falls back to point C. Which of the following is true about the ball's velocity and acceleration at its highest point B? Its velocity is 0, and its acceleration is down and non-zero. In fact, its acceleration would be -10 meters per second squared. So the reason is we have a positive velocity up. Okay, so positive velocity up. Our velocity is negative coming back down because that's defined by the direction we're traveling in. And so to go from a positive number, so like right here, we're at 1 meter per second. Right here, we're at -1 meter per second. So that means right here, we have to be at 0. You have to pass through 0 instantaneously. The habit is, let me pause to deal with my son having a nightmare. So the trick here is people are going to tend to interpret this as, Well, at the top, if my velocity is 0, my acceleration must be 0. Well, keep in mind that acceleration is a change in velocity. So if that were true, you're not moving and your velocity is not going to change, which means you should just hover. And if you've ever thrown something up in the air and it hovered, there's some weird crap going on. Get out of the house. That is not the case. So your acceleration while the ball is in the air is always, always, always negative 10 meters per second squared because gravity does not turn off. Okay, so number 10. Archer practicing with an arrow shoots a bow with an arrow bow. That's the great worded question. Shoots an arrow straight up 2 times. Initial speed is v naught, and the second time he increases the initial speed to 4 v naught. How would you compare the maximum height in the second trial to that of the fourth trial? Or sorry, the first trial, it's going to be 16 times greater. 4 times the velocity means it's going to go up 4 times higher. Now, how do I know that? Well, first of all, this becomes easier down the line with something called conservation of energy, but that's down the line. How do we do this with kinematics? Well, so what we got here is we know V naught. At the top, we just discussed in problem 9, we know at the very, very tippity top our final velocity is 0. So we know our final velocity is 0. We're given a V naught of V naught. You can make it whatever number you want, 1 and 4 or 2 and 8 or 4 and 16, or just leave it as a variable. It's completely up to you. We know acceleration is that constant value of negative 10, but I'm not going to actually plug in numbers, so I'm going to plug in the variable for it, which is g. Little g always means negative 10 meters per second squared. And then delta y in this case is what we want. Time is the variable we do not have, which means v squared equals v naught squared plus 2 times a times delta y. Well, we know v naught squared is, or v squared is 0, right? And we know that this here is negative 10. I lied. I'll go ahead and put the numbers in. That's fine. All right. So if I subtract v naught over here, I get, 2 times negative 10. So the negatives go away. No one cares. So here's the thing. To find your displacement, you're going to divide by 20, but you're going to do that whether it's v naught or 4 v naught. So that doesn't matter. It's not going to change your answer. But the thing is you have to square your velocity to get your displacement. The displacement is proportional to the square of your initial velocity. V naught means it's proportional to v squared. 4 v naught means it's proportional to 16 v naught squared because you have to square both. So that's where the 16 times greater is. It's proportional to v naught squared. All right, now we're on to the free response problems. Can fit this all on one page, mostly. Excellent. All right, here we go. So object accelerates. So again, hold on. Yeah, okay, fine. All right, so I'm gonna do these quickly because it's late and I have other stuff to do. So object accelerates from rest, so that means v naught is 0. This is v. This is delta x. Again, looking at the units from rest, that's just the classic v naught is 0. Meters per second has to be velocity. Meters is distance. So displacement, what was its acceleration? So we're looking for A. The thing I have not listed is time. So that means v squared equals v naught squared plus 2a delta x. So 6.2 squared equals 0 squared plus 2 times a times 5. That means 6.2 squared is a number, which is 38.44. Equals 10a. So divide both sides by 10 and you get an acceleration of 3.84 meters per second squared. Number 2, a sled with no initial velocity. So here, I'll change questions colors every question just so you can see the difference. Sled with no initial velocity, so v naught equals 0, accelerates at a rate of 3.2 meters per second squared. So that's acceleration. How long does it take? So that's going to be time. Now, I should underline how long does it take, because how long does it travel is a really awkward way, but valid way of asking for displacement. To go 15 meters, so that's delta x. So I've got v naught, I've got a, I've got t, I've got delta x. There is no v, so I'm going to use my equation without v, which is delta x equals v naught t plus 1/2 at squared. And I'm going to go ahead and plug everything in. So it's 15 meters equals 0 plus, again, for the sake of speed, if V naught is 0, this whole term goes away because anything times 0 is 0, and adding 0 to anything is pointless. So that whole term goes away. 1/2 A times t squared. So to get rid of the half, I multiply both sides by 2. So I get 30 equals 3.2 t squared. Divide both sides by 3.2. And take the square root, and the square root of 30 divided by 3.2 is 3.06 seconds. Changing colors. Number 3, an object accelerates from rest. Well, this test was big on v naught is 0 with a constant acceleration of 5.2 meters per second squared, so that's acceleration. What will its velocity be? So we're looking for v after 3 seconds. That's time. So v naught a v t, I do not have delta x. So I will use the equation without delta x, which is v equals at plus v naught. So that's going to be v equals 5.2 times 3 plus 0. So that's going to be equal to, let's see, 5 times 3 is 15, 15.6 meters per second. Number 4, an object is moving. Hey, we have an initial velocity of 12 meters per second. It accelerates at a rate of 1.5 meters per second squared over a distance of 40 meters. What is its new velocity? So I'm looking for v. Again, I do not have delta x, so I'm going to use the same equation. V equals at plus v naught. So that is going to be v equals, I covered it up. That looks like 1.5 times, oh, hey. I am so very wrong. I am very, very wrong. We don't have t. T is what we are missing. I'm cruising on autopilot and screwing up. So if we're missing t, we're going to go ahead and use v squared equals v naught squared plus 2 times a times delta x. I mean, that was all on purpose. I did it to test you in a video that I will not interact with you on. So our initial velocity, we're looking for v, so that's v squared, equals 12 squared plus 2 times a times delta x. So let's see here. 1.5 times 40 is going to be 60, times 2 is going to be 120. So I'm going to move over to the left here. I've got v squared equals 144, which is 12 squared, plus 120, which is 2 times 1.5 times 40. 144 plus 120 should be 264. And then I take the square root of that to get rid of the square root here, and the square root of 264 is 16.25. 16.25 meters per second squared. Now you do need to pick a positive or negative number. In this case, I'm going to leave it positive because they don't indicate directions at all. So we assume they're all positive if there's no indication there. All right, Apollo rolls along the floor with a constant velocity of v. So that's v naught technically. How far will it have gone? So we're looking for delta x after 6 seconds. So that's going to be time. Now, here's the one thing. This is a constant velocity problem. They say it's constant velocity. So the equation there is delta x equals vt. Now, how do you know that? Because here they give you this, but we don't give you that equation at all. So the idea here is if it says constant velocity, you should know your acceleration is 0. And delta x equals vt plus v naught, plus 1/2 at squared. If your acceleration is 0, everything in this term gets multiplied by 0, so it goes away, and it leaves you with delta x equals vt. the other two equations, if you plug in A is 0, you just get V equals V, which also should make sense for constant velocity. So yeah, this is just going to be delta x equals 12 times 6. That should be 12 times 6, which I should not be having this much trouble with. It would be 72 meters. And then finally, oh, hey, I haven't been changing colors for like 3 problems. That's brilliant of me. Stump rocket takes 3.1 seconds, so that's t, to reach its maximum height. So as soon as I see maximum height, what I'm immediately thinking is v equals 0. Because at the maximum height, your final velocity is 0. Your velocity at your maximum height is 0. I also know that my acceleration is negative 10 meters per second squared. So it says, what is my initial velocity? So in this case, I do not care about delta x. So using the equation without it, it's v equals at plus v naught. V is 0, a is negative 10, t is 3.1, plus v naught. So if you go ahead and solve that, you get that v naught must equal 31 meters per second squared. And then what is its maximum height? Well, now we just solve for delta x, so, or in this case, delta y, because it's vertical. So I'm going to go ahead and use the equation that's already set equal to displacement. So what you do is you get your answer from before times t plus 1/2 a times t squared. And if you plug all that into your calculator, you get 31 times 3.1 is 96.1. 0.5 times negative 10 times 3.1 squared is negative 48.05. Add that to the 96.1, and you get 48.05 meters. And that's it.